learners, thank you for tuning in again for our math literacy class on bar and number scales. Did you know that we use scales to reduce or enlarge sizes of objects? For an example, we know the actual size of a car, but when we see it on a picture, on a paper, we can see that the size has actually been reduced. That is where scales come in. At the end of this lesson, you should be able to express scales in appropriate forms. You should be able to read information from scales, be able to explain advantages and disadvantages of a bar and a number scales, be able to calculate actual distances. The conceptual mind map that we're going to be using in this particular lesson will be based on scales, number scale, as well as a bar scale. You should know by now how to work with ratios and how to measure length and distance. Let's express the following units in unit ratios. What does a unit ratio mean? It means that the answer that you get should give you 1:2 something. So we are expressing it in a unit ratio that 1:2 something. So if we are to express number A, 2:4 as a unit ratio, what do? You first have to check whether does the number on our left-hand side go into the number on our right-hand side. If it does, then you can divide by the very same number and check whether does it leave your answer in the form of 1:2 something. Let's do that. When we say 2 divided by 2, what do we get? We get 1:2 something. Then we say 4 divided by 2. So whatever we do on our left-hand side, we must also do on our right. So the very same number that we divided with on our left-hand side, we should also divide with on our right-hand side. So we're going to have what is 4 divided by 2? It gives us 2. So it means this ratio expressed in a unit ratio or a unit form is 1:2. Then we go to the next one. We also check, does 25 go into 75? Yes, it does. Then we can check whether when we divide by 25, what are we left with on our right-hand side? So we say 25 divided by 25 will give us 1:2. What is 75 divided by 25? 25 goes 3 times into 75 because it's 25, 50, then 75. So it's 3. Then it means the expressed unit ratio is 1:3. Then we go to 250 is to 1,000. So does 250 go into 1,000? Yes, it basically does. So when we divide both sides by 250, then we say on our left-hand side we'll remain with 1 because 250 divided by 250 is 1. Then what is 1,000 divided by 250? We've got 250, 500, 750, then it's 1,000. So it means it goes 4 times. So some of these calculations, they generally don't need a calculator. Then we go to the next one, D, which is 14:18. Then we can check, does 14 go into 80? Generally would think that it doesn't go, but there is a number that can go both in both numbers. But that is not the intention of this exercise. The intention is to leave our answer in a unit ratio. So it doesn't matter whether 14 goes into 80 without leaving a remainder or not. You just have to divide by 14 so that you can be left with 1 on your left-hand side. So we divide by 14 both sides. Then what is 14 divided by 14? It's a 1. Then what is 80 divided? Then now you need your calculator. Let's punch 80 divided by 14. We get, it's actually 40/7. It's 40/7. You can leave it as a decimal number, which will be 1:2. What is 40/7? It's 5.71. So that is your unit ratio. Then we do the last one, 175 is to 125. 175, we can already see that it's bigger than 125, but the intention is to leave our left-hand side being 1. So we divide both sides by 175, and then even 125 divided by 175. So 175 divided by 175 gives us 1. What is 125 divided by 175? Let's do it on our calculators. 175, it gives us 5/7, which you can leave as a decimal number. Then it says 5/7 is 0.71. Then question 2 says, if the distance between 2 towns is 43 kilometers, how far apart are they in centimeters? Now we have to convert from kilometers to centimeters. Remember the method that we once did that says, Keke hates doing math during cold months. So where are we moving from? Kilometers to centimeters. So what do? We multiply by the number of times we'll be moving. So you put a 1 on the kilometer and it zeros up until where you're going. So it's actually 100,000. So we're going to say 43 multiplied by 100,000. So what is 43 multiplied by 100,000? It gives us 430,000. Is it 430,000 or 4 million? Let's check. 43 multiplied by 100,000. It gives us 4,300,000. 4,300,000. Then we go to the next one. A car is parked 670 millimeters from the pavement. How far is the car from the pavement in meters? So you're converting from millimeter to meter. We check millimeter to meter. So you put a 1 and zeros up until where you're going, but we are dividing. So it means we're going to say 670 divided by 1,000. What is 670 divided by 1,000? 670. Let's do it together. Divided by 1,000, it gives us 0.67 meters. Let's not forget to put in the new units, which is centimeters, and here it's meters. Okay, then the next question, calculate the total distance of a snail. Calculate the total distance a snail moved in a day. If it moved 62 centimeters, then another 123 millimeter, then finally 0.5 meter. Give your answer in centimeters. So it means we must convert all our units to centimeters. The first one that we have is 62 centimeters. There's no need to convert that. Then we have to convert millimeters to centimeter. We said KK hates doing math during cold months. So we are moving from millimeter to centimeter. It means we divide by 10. So what is 123 millimeter divided by 10? It gives us 12,3 centimeters. Then the last one, we have to convert the 0.54 meter to centimeters. So meter to centimeter, we're moving from M to C. Then it's going to be a 1 and 2 zeros. Then we are multiplying. So what is 0.54 times 100? 0.54 times 100, it gives us 54 centimeters. So we multiply by 100. Let's erase that. Then it gives us 54 centimeters. Then we add everything together because they wanted the total distance. So we're going to say 62 centimeter plus 12.3 centimeters plus 54 centimeters. What total centimeters are we getting? So we say 62 plus 12.3 plus 54. It gives us 128.3 centimeters. So this is the total distance that the snail moved in that particular day. The new words and language that we'll be focusing on, the first one is a scale drawing. A scale drawing is a drawing or a map which represents the size of the picture on the drawing in relation to its actual size. So if this was a table of some sort, the actual sizes will be 8 meter and 3 meter, which will be reduced because it has to be drawn on a piece of paper. It will be reduced by a scale of 1:30. It means it is 30 whatever units less than its actual size. Then we go to the scale factor, the factor by which the size of the real object is either reduced or enlarged. For an example, the bus is drawn 100 times smaller than its actual size. Obviously, we know that we cannot draw a bus with its actual size on a piece of paper, so we have to reduce this. So that is the scale factor. Then dimensions. The dimensions are the measurements of an object which describes its size in terms of the length, the width, the breadth, and the height. For an example, the dimensions of an aeroplane, it has a length of 30 meters and it also has a width of 28 meters. Numeric scale is a scale that is written in a form of a unit ratio format. So unit ratio format, it's written in the form of a ratio, but it should be a unit which is 1:5. Normally we represent it as a unit ratio where it's 1:something all the time. Then we have a bar scale. A bar scale is a graphical representation of a scale by means of lines with ruler markings and units that are proportional to the scale. So we've got a scale, but it's a picture scale in a way, and then it gives us the relation of the bar, which should be measured in relation to its actual size, which are these units that are given to us there. So let's take a quick break and then we'll continue afterwards.